Hello, class. I am so glad everyone is here today. I want to wish you happy Earth Week, and Friday is Earth Day. So this is so appropriate because we're starting our last section of the semester, which is the study of the Earth structure. So today, what I'm going to show you is the Earth structure plays a part in the theory of tectonic plates. Their movement leads to the creation of geological features, natural hazards, and the prediction of them. So the first thing we need to do is to learn about the structure of the Earth. So what I want you to do is take out your handout that's entitled Cross-Section of Earth, and we're going to go through it. So there is 5 layers that I want you to know. Actually, there's a lot of layers. These 5 layers is what I want you to know. So there's the inner core and the outer core. And then between that and the crust is the lower mantle and the upper mantle. And then the crust floats on top of the upper mantle. And in the crust, we have continental and the oceanic, which is under the water. So those are the 5 layers that I want you to know about on the Earth's structure. So, is there any question about these 5 layers? And if there isn't, then we can move on to plate tectonics. I see there's no questions. So, plate tectonics. The definition of plate tectonics is a theory in geology where the lithosphere, which is our crust, is divided into small numbers of plates, which float on top of the mantle. These plates travel independently over the mantle. So the Earth's surface is always moving. So this was a theory, the geological theory of Alfred Wegener. He originally proposed it in 1912, and it was a continental drift theory. So what I want you to do is pull your other handout that's titled Earth Through Time, and we're going to go through the theory, and we'll show you what he thought it was. So about 200 million years ago, there was this land mass called Pangaea, one single landmass. It started breaking up about 200 million years ago, and in the northern hemisphere, it was Laurasia. In the southern hemisphere was Gondwana land. Now, this just kept breaking up over and over until what we have today. So over 200 million years, we went from 2 Earth masses to what we have. So he had found, when they found coal in Antarctica, Wegener made the conclusion that this must have been somewhere near the equator at one time. So that's when he proposed his theory to the science community, and they rejected it. So it was not fully accepted until the 1960s, and it was known as the continental drift, and it is a part of the plate tectonics theory. And it's this theory that explains earthquakes, volcanoes, mountain ranges, and ore deposits. So plate tectonics is as important to earth science as the structure of an atom is to physics and chemistry. The Earth's surface is broken up into plates, and these plates move. There are 8 major plates and dozens of minor plates. They change position, they change size, and on average, they're about 50 miles thick. They set up on top of the upper mantle, and because of its plastic composition, it allows them to move independently. They move in 3 different ways. The first way, they move towards each other, which is convergence. That can be continental to continental. It could be a continental to ocean. It could be an ocean to ocean. Second way they move is divergence. That is moving apart from each other. And the third is transformance, which they sit side by side and one moves one direction, the other moves the other way. When these plates move, we get what we call a natural disaster, which is earthquakes and volcanoes and tsunamis. But we also get geological features such as mountains and rift valleys and islands. And it's because of the threat of natural disasters and the devastation that they cause, there is a worldwide system that monitors seismic activity. And this monitoring can pinpoint exactly where the seismic activity occurs, how strong it is, and how often it occurs. And it can tell us which plate is in movement and what region. Each region has a history of natural disasters. And with these monitoring of the seismic activity, we can predict earthquakes, be it on land or in the water. The water causes tsunamis, or it could be volcanoes. Volcanoes can concurrently happen with an earthquake, or after seismic activity has been building up over a time period, that can cause them as well. So let's review Earth's structure and how it plays a part of the plate tectonics. The Earth is made up of a core and a mantle and a crust. It's the mantle's composition that allows the crust to float. The crust is broken up into plates, and these plates move in different ways. The first way is convergence, and the second is divergence, and the third is transformance. Resulting effects of these movements can be natural hazards such as earthquakes and tsunamis and volcanoes. But we also get mountains and rift valleys and islands. And the precision monitoring of these plates through seismic activities can allow us to predict the natural hazard and plan for the possible impact. I want to thank you for being such a great class today, and I want you to remember your homework and your 1,000-word essay are due on May 1st. Both these assignments must be typed. So have a great week, and I will see you again on Earth Day.